the whole process of creating a virtual representation of all our physical resources. You know, we have our CPU, your storages, and memory. So creating kind of a logical representation or a virtual representation is what we call virtualization. So virtualization will actually introduce kind of a layer, like a layer that will separate hardware from operating systems. So when we do virtualization, the system will be more flexible, and that can help us to scale more in this computing environment. So, so when we look at virtualization, so we have, excuse me. So we have a few points, right? A few key points of virtualization, such as you have multiple machines or multiple computers, but we refer to them as multiple virtual machines. So these are just virtual. So when you think of virtualization, think of what you can have physically, but we make them, we get the virtual representation. When we are in virtualization, so you see, for example, your operating system, you can have one app or one system, but you have multiple operating systems that are running different parts of your organization. All right. So in virtualization, so virtualization would actually remove that relationship between hardware and software by just introducing a logical layer which will manage your physical resources. So in virtualization, we have multiple VMs or virtual machine that can run on a single physical server. All right, so one single physical server is running multiple virtual machines. What just happened to the slide? Okay. All right, so you have multiple virtual machines that can run on a single physical layer, which means that all these machines are sharing the same CPU, the same memory, and the same input-output resources, such as your whatever inputs resources you are using, can be keyboard, mouse, or anything like that. So it's like you are running multiple computers by using one machine. All right, so that is virtualization. So another key point of virtualization is the what we can refer to as an isolation, because the virtual machine will share the same hardware. Despite the fact that they are sharing the same hardware, they will remain virtually isolated. So virtually, it's multiple machines, but physically, they are all using one hardware. All right. So they are running on one physical server. So in virtualization, although VMs share the same hardware, these VMs, which are virtual machines, remain logically isolated, right? Why? Because action in one machine, virtual machine, do not affect others. All right. So an action in one virtual machine will not really affect the other machines. All right. So, and then you have another point. Oh, why is this frozen? Okay, so and then you will have another point, which is the you need to note that virtualization is actually the core foundation of cloud computing, because that's the whole point of cloud computing. Cloud computing means that instead of you using your hard drive and everything, but we are using the memory online, right, on a certain cloud. So the whole cloud computing technology is based on virtualization. All right, because all these data centers are allocating and managing computing resources across many users and workloads. All right, so that's what it means. So in computer science terms, when virtualization will create kind of a layer over the hardware to just enable you to control everything by simulating hard drive devices. So everything is virtual. You have your separate environment, which means you have multiple virtual machines that are isolated in terms of how they work, but they are all using the same the same devices. All right. So in virtual machine, there's an history behind it. A virtual machine is something that started long time ago, since the 1964, where we had IBM introducing Big Blue, right? So in 1964, Big Blue, which is an IBM. So IBM began experimenting with virtualization on mainframes. That's how they started with what they call Big Blue. And then in 1972, you have IBM that officially named System 370 time sharing system. They've named it virtual machines, right? So that's when in 1972, IBM has launched all the virtual machines running on mainframe, and that system was officially named System 370. And then you have in 1999, where we have VMware, which introduced the first virtualization products to run on x86 architecture. So that is what happened there. And then, so this kind of an history up to 2011, where everything has grown to a point where now IBM, you have Red Hat, you have HP, and Intel that were able to establish the Open Virtualization Alliance, just to accelerate all the KVM promotions. All right, so so what you need to understand that with this development of virtualization. So in 1964, we have kind of the beginning based on the IB mainframe, and the whole goal of this, when the virtualization starts, the whole goal was to just allow multiple users to share a single physical computer simultaneously through time sharing. All right. So, and then in 1972, that's when we consider the birth of virtual machine concept. Okay, so you need to know that. So the birth of virtual machine concept is in 1972. So this marked like the formal birth of virtualization technology, which means multiple virtual machines are running now on a single mainframe, each with its own operating system, as we previously mentioned. All right. So there is a few characteristics of virtualization. All right. So there's a few characteristics of virtualization. So you need to understand that when we look at virtualization, as we've mentioned, things like the isolation, it means like the virtual machines are running on the same physical server, but they are isolated from each other. So anything that you do on one machine doesn't mean it's affecting the other machines. All right. It's not because they are all using one physical server that they are being affected by the other machines. They are not. All right. So you need to understand that that is one of the main characteristics of virtualization. All right. So you need to know that virtualization will just provide that logical layer that will separate software from physical hardware. which will enable us to just use the resources efficiently, manage them properly. So you basically have all these VMs that are installed on one server, but they can have different operating system and different users. All right. So in terms of virtualization type, you have full virtualization. You can have a full virtualization, or you can have a para-virtualization or a hardware-assisted virtualization. So a full virtualization will mean that the virtual machine will virtualize that you have the CPU, the memory, the input outputs devices. So you have this without without modifying the guest operating system or an hardware, right? So a full virtualization, so you will have all these devices, the CPU, whatever. So this is similar to just having a cloud out there. So you have an application, but everything else, you are not using your own memory, you are not using your own computers, but you are using an external service, okay, which is installed on a different server, which you may not control fully, but everything is virtual there, okay? Right, so, and then you have the para-virtualization, and you have the hardware assisting virtualization. All right, so you have a few advantages of virtualization. So before, when we look at virtualization, virtualization changes how computing resources are managed, right? So there's many problems that we could call problem of traditional infrastructures way. So with the normal infrastructure that we know of having a computer, the CPU, and all these things locally, there is many problems that we can have there. But virtualization has solved many of these problems. So before virtualization, all the operating systems are bound to physical servers. That means you need to have a physical server. So if you open a business, it means that all your servers are in some room close to you, or in your office, or in your establishment. But with virtualization, it's not like that. You may not have access to all those servers, but you can actually subscribe to a certain service that will give you access to those servers. So before virtualization, each operating system was tied to a specific physical server, right? Which means that there was a difficulty in terms of migration because you are moving the workloads between servers. It becomes too complex and time consuming, right? Which means the migration is really difficult and the stability will be unreliable, right? So the stability will be really unreliable, which means that your hardware or operating system failures could take down critical applications, right? You see, you have certain applications and then they get affected. Why? Because of the stability of the system. All right. So, and another issue is you may be affected to a very poor scalability, right? That scaling will be really hard if you want to expand the capacity of your business or your organization. It means that you will require purchasing and configuring new servers. So you have to buy new servers every time you want to grow. So that means that the scaling is really hard, right? And you have some low resources. Why? Because many servers run on low CPUs, memory usage. So you have a high cost that will be involved here because more servers means that you have higher power. It means you will need to have higher cooling system. It means the maintenance is going to be too high. So that means everything will create a certain cost if you want to use things physically, and you will really, and this server will take a lot of space, right? So the space consumption is also going to be one of the factors. You understand? So when you look at large data center, um, they really require to these data centers. So you need like a large data center, like such a big house with all physical servers. That's what you will need if you want to actually use the traditional way. All right. But after virtualization, what happened is that now your load, you don't need to buy so many computers or servers because everything is now done on the cloud. So after virtualization, you have your virtual machines that run independently of the physical servers, which means that the migration will become easy because you can move virtual machines across servers without any downtime. You do a live migration, so there's no machine to unplug and go plug it somewhere else. You're just moving everything online, and then you can easily scale because your resources like CPU, memory can be just adjusted. They can be adjusted because everything is virtual. So there's a very simplified integration of that, and you can easily integrate with cloud systems. There's better security and management. So multiple VMs obviously share the same hardware. But now in this case, now you will have less cost. The cost is reduced. Why? Because you need fewer servers. You have lower power that is needed because most of our servers are just online. You have the cooling system that can be controlled, the maintenance expenses. You don't need to be maintaining some machines and things like that. Why? Because you already have everything online there, right? So there is a few issues that can arise with virtualizations. So there's two issues that we can actually identify from here. Is that we have a simulation of CPU instruction, and then we have enabling multiple VMs to share the CPUs. So CPU virtualization is one of the core components of virtualization technologies, guys. So why? It's because this is what address how multiple VMs, virtual machine, can safely share the same physical CPU and interfere with each other. So simulating the simulation of CPU instruction is very sensitive. It's a sensitive instruction. Why is this? Because sensitive instructions are CPU command that can read or modify key system, such as memory mapping. So we basically see how the memory is going to be shared, like interrupting tables or input output port. So examples, you have your instructions that control system registers or privilege levels. That means saying which software is to be privileged in terms of the operation. So your privilege instructions are going to be sensitive instructions that can only be executed in kernel mode. So if a non-privileged program like the virtual machine guest operating system attempts to just execute uh, this privilege instruction directly, it will kind of trigger a trap to the virtual machine monitor, which is also called the hypervisor, right? So these sensitive instructions are to be really watched. They are very. That's why they call them sensitive instructions. You understand? So because you understand that this instruction can read or modify the key system resources. So this is one of the challenges of CPU virtualization. So CPU virtualization will ensure that CPU virtualization will ensure that these sensitive or privileged instructions are safely intercepted and simulated by the hypervisor, which will prevent the guest operating system from directly accessing hardware resources. Okay, so the second challenge will be to enable multiple VMs to share CPU. So when we look at the hypervisor, why am I saying hypervisor? The hypervisor. So the hypervisor needs to ensure that that multiple VMs can share one or more physical CPU. Okay, it ensures that these VMs are sharing the same physical CPU, but it needs to maintain the isolation, which means that if there's problem with one computer, it shouldn't affect the other one. All right, so how will the hypervisor achieve that? It's going to achieve that by a few mechanisms. So it's going to use what we call a time interruption mechanism. Okay, so the time interruption mechanism. So that will help like the CPU timer to generate all the interrupts. So in each interrupt will trigger the VMM schedule. You understand? So and then the scheduler then decide which virtual machine get CPU time next. You understand? So how the CPU time is being controlled. So which VM as the priority. You understand? So all those things. So this is how we're going to actually deal with that. Okay. So CPU virtualization. So you need to understand what is CPU virtualization. So basically, CPU virtualization, you have your the figure that we have here, which is actually showing what we call a fusion compute. So a fusion compute is just what we the Huawei's virtualization platform will use certain hardware assisted full virtualization, which will enable you to have some virtual machine to share the same physical CPU. So when you understand the CPU privilege levels, so on the CPU privilege level, we have about 4 privilege levels. So the 4 privilege level, we have the ring 0, ring 1, ring 2, and ring 3. These are just privilege levels. So the CPU, this x86 CPU architecture, which has defined the 4 privilege levels, which will just help to control the access to the hardware and to the memory. I think you can see that even when you search on your computer, on your Windows computer, you want to see more details about your hard drive or your system itself, your computer. You will see it's going to tell you the type of hardware. So your ring 0 will be the highest privileged. So on the ring 0, you have the operating system kernel mode. That means that it has full access to hardware and can execute the privileged instructions. All right. And then you have your ring 1 and 2, which has a medium privilege, which is rarely used. Okay. Historically, it was just intended for device drivers or middleware, but now we don't have a lot of device drivers. People don't use those CDs, DVDs, and all those things. So, and then you have your ring 3. Your ring 3 would be the lowest privilege. So this is basically the user mode. Okay. It's going to run all application codes with no hardware access. All right, so how the CPU will execute the operating system and application code. So you have operating systems such as Linux or Windows needs to run in what you call this in ring 0 to access the hardware and control the memory. So that's the operating system. So the operating system run on 0, but on ring 3, that's when we're going to have the rest of the application. So the rest of the applications will run in ring 3. And when they need to perform like restricted operation, like accessing a file or disk, they use the system calls. So the CPU will temporarily switch from ring 3, right, to ring 0 to execute the kernel code. Then back to ring 3. That is if you do a certain operation on a certain application. So that's how the instruction is sent. Okay, so the switching process from ring 0, ring 1, ring 3, that is the process that is called user mode to kernel mode. So we are user mode to kernel mode transition. All right. All right, guys. I think this will be all for clouds today. Yeah, we'll pick it up from tomorrow. But for today, we still have AI in 15 minutes. So by 6:45. All right, guys, I'm going to see you in the AI class in 10 or 12 minutes.